Alright, welcome back to my 15 days of doing the daily Leetcode challenge. So let's start diving into it. So today's Leetcode problem is a gem gain 5 and it's a hard problem. By seeing that, don't get shocked or panic if you have chance to solve this problem in the interview. So let's try to understand the problem first. So we are given an array of integer variable name r and the integer d. We don't know what is the d is. In one step, we can jump from index I index to another index. So I plus x is arbitrary value what we can define, but there is a clause for it where I plus x must be less than to the array of lunch. That's definitely sure, because if we get out of more than the array, that could cause the array index out of bound. And then the x value should be between 0 and d. So that means that let's consider we have given the d is 2 in here. So that means the x value that we could jump from the each index should be 0 to 2. That means 1 or 2. That is the only option we have. What about I minus x? If we want to go through the index minus x, that definitely need to be greater than the 0 and at least minimum 0. The reason why is, let's say you are in the index of 0, we don't want to go beyond that 0 because there's no value or no index beyond that. So there is a one cause, and another one is even if we are doing that, the x value should be in between or from 0 to 2 according to the XML1. So we know like what is the d minutes in here, instead of like explanation of d is a distance or something. They mention like the value d is an arbitrary value that we could jump in between or within the array scope and then plus or minus to the value of d. So in addition, we can jump from index I to index j if array of index is greater than the array of j. So what do I mean by that? Even if you want to jump from one place to second place like this, we have to keep in mind that the value should be always less than the original value of the index that we are standing. So the great example is, let's say we are standing in the here, which is index 10 with the value of 12. We can jump to, let's call like d is 5. We can jump to there, but we are not allowed to jump it. The reason why we are not allowed to jump is the value of the index 5 is 13, which is 1 point larger than here. So all the place we can only jump is, let's say we're gonna jump there, we can only jump to the here, and here, because all the value of the other indices from 6 to 9 is smaller than the original value of our index 10. Alright, cool. And yeah, that is about the dispersion, and we also need to keep in mind that index I, the next step should be smaller than the original value. Let's say if we jump from 12 to 10, this became our standing point, and then we are not allowed to jump to the higher place like this. So we can only jump to the place like 9, 7, 6 with the consideration of the distance d. Alright, what we need to do is we have to return the maximum number of indices that we can visit. And there's a one note from the question. We're gonna jump outside of the array at any time, right? That makes sense, because we should be inside the array and we are not allowed to jump there or jump there, which is not allowed in here. Alright, let's go through the XML1 in here. What I can think of it is, this is dynamic programming for sure, because I know the pattern when I see the inputs of the question. And what we could do, or what I would suggest, is when it comes to dynamic programming with a huge data set like this, according to them, we have a constraint from array length is 1 to 1000 that is considered huge, and we could do the memorization, like keep track of what are the value that we had done in the past. Okay, how about we create the one array called memoization. Let's call it memoization, and then with all the numbers in here, 2, 3, 4. Okay, total is 11. 4, 5, 6, 7, 8, 9, 10, 11. So that way 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. And I would love to have another variation from index 1, 2, 3, 4, 5, 6, 7, and oops, make a lot of mistake. 8 and 9 and 10. Okay, cool. So we got what we want in here. There we go. So we have indices above So we have index above and the memoization value here. Let's consider we are doing the brute force way. What if I am in the position of the index 0? There's only two ways I can jump. It's this area, because the value of the D here is a 2 in here. So we're gonna jump more than that. So in terms of like jumping perspective, we are not allowed to jump from 6 to 14 for sure. Why? Because there is a limitation about our array of the original index should always be greater than the next step. So we are not allowed to jump there. And then where do we jump? Quite simple. Jump from 0 to 1. And then so we're gonna shift from 4 to here because we are now at the position of the 4, and then we can check like all the valuation of the next step. 14 and 16 are larger than our original. So what I would do is we increment the index 0 to 2. You could have a question like, why change the memoization to 2 and not 1? So the value in here that they want to measure is we jump from 10, 8, 8, 6, 7, that is totally 4. So we have to count like 2 place, which is 2. So the original even have to count inclusive so that we could get the correct value. So let's move to the 4 in here. For the 4, we are not allowed to jump to any place. So that will be only 1 in here. So starting to be very easy, right? But keep in mind with first. So okay, don't know why I cannot delete it. Okay, cool. We are in a good trap. For the 4, we are not allowed to jump to any place. Why? Even the left is 6 and right is 40 and 6. So we have no chance to jump over it. So let's move to place called 14. So for 14, we have a lot of option. Like the 40 can jump to a lot of place. Something like 6. From 14, we jump to 6. But we cannot jump to the same place. So from here 6, we can jump to 4. 1, 2, 3. But we can consider, is it the best approach? We have to think about it also. How about jump from 14 to 8, right? And then we jump to the we have 2 approach in here. 1, 2. Okay, so even though if we jump to the A, there's only 2 approach. 1, 2, 3. For the orange, 1, 2, 3. For the blue color. Alright, cool. So that will be the value of 3 in here. So, and then how about the place of, wait, I'm so terrible at editing this. how about the index 3 where we can jump? So index 3 is here, and I'm gonna draw the 2 place, and then we are at here. So definitely sure we are not allowed to jump to any, cannot jump to any place. So the best option here is 1, because which is only one approach here. Moving forward from 6 to the 8 in here, I did for the index of 4, 8, we could jump to the 6. So we have to be in limit. So you guys might think like, what if we jump from one place to another? We have to keep in mind that our originator place is always the index that we are at the moment right now. Let's say like we jump from 8 to 6. We cannot expand our window from like this because our originated value is here, which is 8. So even for the 8, we can only jump to one place. That's why it is only 1 in here for the index 4. But sorry, it should be 2 because we can jump to 8 and 6. Okay, how about the 6? Let's check back together. If it is 6 and we move like this, so we can go any place. All right, cool. And okay, now we are at the place of, I need to clean up this again. Sorry about that, I'm not quite used to it. And we are at the index 4 is done. How about the index 5, which is here? Let's move to the index 5. There we go, and we just began the center, and we have a lot of options in here. So for the 13, we can jump like from 13 to the 8, and then 13 to maybe something like this. 13 to the, I will jump to the okay, index 4 is A one time, so index 5 is 13. We can jump to value like 8, 9, 9, 8, or like this, 7. So total will be the 3. So I hope you guys got the problem. I'm trying to save the time. I will not go all the way around. So let's try to write the code first. Let's call, we need the one valuation called count. I want want to calculate the size of the array every time throughout the problem. And I'm gonna use the things called memorization, which is the array and repeating of the 0 at the first, and then count will be the count. All right, so we got what we got, and I will keep the origin of the answer as 1 first, and what I want is for index in 0 through count. So that will be, okay, I'm gonna update the answer with the valuation of max from answer plus, we need the one function here. Let's call it the depth search with the index of integer, and we're gonna return the in here. Let's return like the 1 first. I don't know what to return, and then I go through like DFS of each index, and then just return the answer in here. All right, so let's think about what are the value we want to return. Since it is going to call the original first, so let's call the best equal to 1. Best equal to 1 means we are at the position of the 12. That means we have a 1 best number in here. Let's try to jump to the right. Let's call J just to follow his naming according to the question. J will be the index plus 1. So we are going to jump to the right. let's go jump right, and I will check the same condition in here that was mentioned. Why our j of cow is still less than the cow, and j is less than no, have to be greater than or equal to index plus our distance. So we got the best in here, which will be the mass of best, or we can do like index 1 plus default search of maybe j, but we need a one break in here, so which is going to be our array of index j have to be greater than the next valuation. Technically we want to check like the index of our current position. Let's say we are at the 12, the next place we are jumping is greater than our current position. We're gonna break our loop, and then I will increment the j with the plus equal 1 because we are jumping to the right. How about jump to the left? That will be index minus 1. So for index minus 1, let's call like jump right, and we still need to check like okay, not jump right, it's the left because we are doing the -1 in here. So even if we want to jump left, we need to think about our valuation is greater than or equal to 0, and our j is within the range of index minus d, and we will still check array of j is still greater than or equal to array of index. If not, we're gonna break it, and we still get the best in here also, mass, and which will be 1 minus 1 plus default search of j in here. So the reason why I'm doing the +1 here is every time I move it, I just want to keep track of like the place I switching its next index. Instead of like going backward, we are going to forward. And I will do the minus equal to the 1, and for sake of the memorization, we will keep that value, the best value in here, and then that will be returning the best. Let's try to run the given test first. Okay, what is round in the... Alright, I can't get the mess of the mess for sure. I have to get the best of the mess. Not sure my solution. Okay, if I am not wrong, I'm gonna do my solution, which is going to be O of d plus n, because I don't use any extra. Okay, that means our memorization is not working properly. We are hitting the things called time limit AZ. I need to check what did I do wrong throughout the program. So we are not even doing anything extra in here, and then we're calling them. Oh, makes sense, because we don't break the memorization in here. Let's call index if not equal to 0. We just return the memorization on index, so that could make sure our memorization is working properly. Cool. And let's check the time complexity and space complexity in here. So if I'm not wrong, the space complexity is O n, because I just used the same size of the array as a given array, and that would be the O of n multiplied by d. Yep, that's pretty much for it. And then hope you guys enjoyed my challenging hard Leetcode problem. And that's all for it, and then see you in the next one. Bye.